In the autumn of 1848, a survey party working the shoreline of Lake Superior stopped digging, not because they'd hit rock, because they'd hit somebody else's work first. Beneath a few feet of moss and soil, they found a pit carved directly into solid copper-bearing rock. Inside it, a stone hammer, worn smooth, a wooden lever still wedged where someone had left it, and no bones, no tools of iron. No record, in any book anyone in that survey party had ever read, of who had done this or when. That pit was one of thousands. Today we know of more than 10,000 ancient mining pits on a single island in this lake, with thousands more along the peninsula across the water. Whoever dug them was extracting nearly pure metallic copper you can pick up and use without ever melting it thousands of years before the pyramids of Giza were built, and long before anyone in this hemisphere had learned to write a word down. So here's what we're actually dealing with tonight. 3 questions. All 3 have partial answers today and by the end of this video. I'll walk you through the actual science that answers them, not folklore, not guesswork. Question 1. Who dug 10,000 mine shafts using nothing but stone and fire, on a scale that some geologists once estimated at well over £1 billion of extracted copper? Question 2. Why does the archaeological record show this work simply stopping tools abandoned mid-task? Pits left half dug with no catastrophe, no war, no obvious reason on the surface? Question 3, and this is the one that pulled me into this story. If a civilization pulled that much copper out of the ground, where did nearly all of it go? It isn't sitting in a warehouse. It isn't buried in a hoard. It has almost entirely vanished from the archaeological record at the mine site itself, except for the fraction that keeps turning up in graves and villages hundreds, and in some cases over 700 miles, from this lake. By the end of this video, I'm going to show you the study that used lake bottom mud actual sediment cores to finally put a real scientific date range on this mining operation after more than a century of failed attempts, and I'm going to show you exactly how researchers proved where the missing copper went, using nothing but chemistry and geography. Not speculation. Isotopes and trade routes you can trace on a map. Stick with me. This is one of the oldest continuously debated mysteries in North American archaeology, and it's finally starting to crack open. To understand why this find rattled people in the 1840s, you need to understand what the Lake Superior region actually is. Along the Keweenaw Peninsula in what's now Michigan, and on Isle Royale, an island roughly 15 miles offshore, the rock itself is unusual. Ancient lava flows here trapped pure metallic copper directly in the stone, not copper ore that needs to be smelted out of rock, but native copper, in some cases in masses so large that 19th century mining crews needed months just to cut a single boulder-sized nugget into pieces they could move by hand. When American mining companies arrived in the 1840s to exploit this deposit industrially, they didn't find untouched wilderness. They found somebody had already been there and had already worked out where the richest copper was. The pits followed the veins with real precision. Early mining engineers, the same men opening deep industrial shafts with blasting powder and steam hoists, kept finding these older workings directly in their path and in several documented cases. Their new industrial shafts intersected the old pits almost exactly. One 19th century mining company's own directors put this in writing. In opening their principal shafts, they said, they had quite literally followed the path of people who had worked the same rock long before them, just with far cruder tools. That's not a modern researcher's interpretation. That's the mining company's own record describing what their engineers found underground in real time. So how did people without metal tools cut through solid rock? The method researchers have reconstructed is called fire setting. You build a fire directly against the rock face. The stone heats, expands, and weakens. Then you douse it sometimes with water hauled up from the lake and the sudden temperature shock cracks the surface. After that, you go in with a hammerstone, a fist-sized rounded rock, swung by hand, to break the weakened stone away piece by piece. It is slow. It is exhausting. And archaeologists have recovered thousands of these hammerstones sitting exactly where they were dropped, some so worn down from repeated use they'd been reduced to smooth, rounded stubs, discarded once they could no longer hold an edge worth swinging. Once the copper was freed from the rock, it still had to be shaped, and this is where it gets more impressive. Native copper is soft enough to be cold hammered directly into tools, knives, spear points, fish hooks, awls, beads, even large ceremonial pieces. No furnace required. Repeated hammering does make the metal brittle, so the toolmakers had learned something else too: periodic heating, without melting, to soften the copper again before continuing to shape it. That's a real metallurgical technique, worked out through trial and error, thousands of years before anyone in this region was working with smelted metal. This tradition even has a name among archaeologists, the Old Copper Complex, referring to the archaic hunter-gatherer societies across the upper Great Lakes who built an entire toolkit around this metal, starting roughly 6,500 years ago. Let that sit for a second. 6,500 years. That is centuries before the first stones of the Great Pyramid were cut in Egypt, and it predates the wheel appearing anywhere in Mesopotamia. And this wasn't a handful of test pits dug by a few curious people passing through. Archaeologists working Isle Royale alone have documented an excavation footprint in the thousands of individual pits with the wider district, including the Keweenaw side of the lake, pushing that number past 10,000. Some estimates of total extraction have run into the hundreds of millions, even billions, of pounds of copper-bearing rock disturbed over the full span of this activity, though. And I want to be straight with you about this, that top-end tonnage figure is disputed among researchers, and we'll come back to exactly why later in this video. What isn't disputed is the scale of organised, sustained labour this represents. This was not incidental. Someone planned this. Someone returned to it, generation after generation, on an island that freezes over and becomes nearly unreachable for half the year. For a long time, the biggest problem wasn't proving the mines existed. It was proving who was digging them, and when, because the later industrial mining, ironically, destroyed a lot of the evidence that would have answered that question. Every time a 19th or 20th century mining crew reopened an ancient pit to get at the same vein, they wiped out the layer of soil and debris that would have let archaeologists date it directly. Researchers also had to reconstruct the practical side of this work. Isle Royale is only reachable by water, and Lake Superior is not forgiven it freezes. It storms. And a mining season there would have been short. That means whoever worked this island wasn't living there year-round. The current understanding is that groups travelled out seasonally, worked the pits during the ice 3 months, and carried finished tools and raw nuggets back to mainland camps before winter closed the crossing. That single detail tells you this wasn't opportunistic digging. It was a planned, recurring expedition, organised around the calendar, repeated across countless generations. Then, in the summer of 1952, a 13-year-old boy named Donald Baldwin was digging in a gravel quarry near Oconto, Wisconsin, nowhere near the mines themselves, and turned up human bones. Archaeologists were called in. And what they found was a burial ground bodies laid to rest with copper tools and ornaments as grave goods. This became one of the clearest, earliest pieces of evidence connecting the Lake Superior copper directly to a living trading culture. People who mined this metal, carried it away from the lake, worked it into finished objects, and buried their dead with it as something valuable enough to take into the next world. That detail matters more than it might sound. This wasn't copper hoarded at the mine site. It was copper on the move, carried, traded, valued hundreds of miles from where it came out of the ground, generations before anyone in this story had a written language to explain why it mattered to them. And that's confirmed by something researchers can actually measure. The copper itself has a chemical fingerprint. Native copper from the Lake Superior Basin carries a distinct elemental signature compared to copper from any other source in North America. That means when archaeologists find a copper bead, knife, or ornament at a dig site far from the lake, they can run the composition and confirm this exact metal came from Isle Royale or the Keweenaw Peninsula and nowhere else. Studies confirming this have traced Great Lakes copper appearing at sites scattered across the eastern half of the continent, physical proof of an exchange network that moved this metal far beyond the people who originally dug it out of the rock. So by this point in our story, a few things are locked in as fact, not speculation. Real people, hunter-gatherer societies of the Archaic period, mined this copper using fire and stone on a seasonal, organized basis. They cold-worked it into tools using a real metallurgical technique. They traded it across an enormous distance, and they valued it enough to bury it with their dead. None of that is the mystery. The mystery is what happens next. For decades, one basic question kept stalling researchers. How long exactly did this mining actually last, and did it happen in one long continuous stretch or in bursts? Earlier generations of archaeologists tried to answer this the conventional way, radiocarbon dating charcoal found near the pits, left over from the fire setting process. But that method kept running into the same wall. Charcoal from an ancient fire can wash downhill, get mixed with charcoal from a completely different century, or simply get destroyed when a later mining crew redug the same spot. Every attempt produced a slightly different, often contradictory chronology. For over 100 years, nobody could say with real confidence when this all began, or how long it truly lasted. So a team of geologists tried something different. Instead of dating the mines, they dated the mess the mining left behind. Every time fire setting cracked open rock and hammerstones crushed it apart, tiny particles of copper, lead, and other metals washed into nearby streams and settled into the mud at the bottom of the lake. That mud builds up in layers, year after year, like tree rings. Researchers pulled sediment cores from Macargo Cove on Isle Royale and measured the metal contamination layer by layer, cross-referencing it against other independent dating methods to lock in a reliable timeline. The result? A continuous, physical, chemically verified record of mining activity spanning roughly from 6,500 to 5,400 years ago, showing that this wasn't one short episode. It was sustained, organized extraction across more than 1,000 years, with clearly visible periods of more and less intense activity. Exactly the pattern you'd expect from a seasonal tradition passed down across dozens of generations rather than a single short-lived project. This is genuinely one of my favorite details in this entire story. The lake was the record keeper the whole time. Nobody needed a written archive. The pollution itself was the archive. Sitting undisturbed at the bottom of a cove for over 6,000 years, waiting for someone with a coring rig to come and read it. And that same sediment record is part of what tells us mining wasn't a single tidy event with a clean beginning and end. It ebbed and surged. Some generations mined heavily, others barely touched the rock. Which brings us to the abandonment question. Why did it eventually wind down? Here's where I have to be honest with you, because this is exactly the kind of moment where lesser channels start inventing an answer. There is no single confirmed cause. This is an active area of research, and I'm not going to pretend otherwise. What we have are several evidence-backed possibilities, not a solved case. 1. Climate shifts across the late Archaic period may have altered how groups moved, hunted, and organized their labor across the year, making a multi-generational mining tradition harder to sustain at the same intensity as conditions changed. 2. As the easiest, most accessible surface copper was worked out over centuries, the remaining deposits required deeper, harder, more dangerous extraction for a shrinking return, a pattern seen in mining traditions worldwide, long before industrial tools made deep extraction practical. 3. Broader social and technological change across the Great Lakes region during the following woodland period, new tool traditions, new trade priorities, the eventual adoption of pottery, and different settlement patterns may have simply shifted what these societies valued and how they spent their labour. None of these require a lost civilization, a hidden catastrophe, or anyone being erased from history. They require exactly what real archaeology usually finds: gradual change, driven by ordinary human pressures, playing out over centuries. Now, the question I promised you at the very start. If people pulled an enormous quantity of copper out of this ground over more than 1,000 years, why does so little of it survive at the mine site itself? Let's deal with the exaggerated version of this claim first, because you'll see it in a lot of other videos on this topic. The idea that a full £1 billion+ of finished copper simply vanished without a trace, as though an entire civilization's worth of metal disappeared overnight. That framing oversells what the evidence actually supports. Total extraction estimates at that scale are disputed among researchers, and much of that figure reflects the total mass of copper-bearing rock disturbed across thousands of pits over 1,000+ years, not a precise count of finished, usable metal that then went missing. Here's what the evidence does support, and it's honestly more interesting than the exaggerated version. The copper that was mined didn't vanish. It moved, and it kept moving for thousands of years after the original miners had stopped. Cold-worked copper tools and ornaments don't corrode away the way iron does. Copper is remarkably durable, which is exactly why we can still test it today. Some of it stayed close to home, buried with people like the ones found near Oconto. But copper from this exact lake also shows up in a much later chapter of the story, one that stretches the mystery even further than most people realize. Roughly 2,000 years ago, long after the original old copper complex mining tradition had wound down, an entirely different set of societies in the Ohio and Mississippi valleys, the Adena, and later. The Hopewell were building enormous earthwork mounds and burying their dead with elaborate ceremonial goods. And when archaeologists analysed the copper in those mounds, copper hammered into breastplates, headdresses, and effigies of falcons and other animals, the isotopic signature keeps pointing back to the same place: the Keweenaw Peninsula, Isle Royale, and the shores of Lake Superior. Some 750 miles from where those mounds were built. Researchers studying this later trade describe it less like ordinary commerce and more like a directed quest, an expedition undertaken specifically to reach this one lake, because the copper from this exact source carried enough prestige and meaning that no substitute would do. That's an extraordinary thing to be able to say with confidence, thousands of years later, not just that copper moved, but that people were willing to travel roughly 750 miles one way, because it specifically had to come from here. So the honest answer to where did it all go isn't a disappearance. It's a nearly 2,000-year afterlife. The copper moved from the original miners into the hands of later societies who never mined it themselves but still knew exactly where it had to come from, and from there into the graves and ceremonial sites we're still excavating today, one isotope match at a time. That's not a disappointing answer. That's a genuinely remarkable one. A Stone Age society, using fire and hand tools. Mined a metal so valued that people were still making deliberate journeys to its exact source line, 2,000 years after the original miners had put down their hammerstones for the last time. So let's go back to that survey crew in 1848, standing over a pit, with a stone hammer and a wooden lever still sitting inside it, with absolutely no idea what they'd found. Here's what we can now tell them, using science they didn't have access to. You're not looking at a mystery with no answer. You're looking at the physical remains of a hunter-gatherer society that organized fire and stone mining on a seasonal industrial scale for well over 1,000 years, cold-worked one of the only naturally pure metals on Earth into tools using a real metallurgical technique, and built a trade network that carried that metal hundreds of miles across the continent during their own lifetime, and then kept being sought out, specifically by entirely different societies, for another 2,000 years after that. The mining stopped, gradually, for reasons that were almost certainly practical and human, not catastrophic. And the copper didn't disappear. It's still out there, in museum drawers, in mound sites still being studied, and in unexcavated ground, waiting for the next isotope match to confirm one more leg of its 6,000-year journey. That's the difference between a story built on speculation and a story built on evidence. One gives you an answer that feels satisfying for 5 minutes. The other gives you a question that real scientists are still actively working on, right now, using better tools than we had even a decade ago, and a metal that, it turns out, was never actually lost. We just hadn't finished tracing where it went. If you want to keep following stories like this one, real archaeology, real disputes, real evidence, no invented history, that's exactly what this channel exists for. Subscribe, and I'll see you in the next investigation.